the questions that I was actually kind of thinking as you were going through the list of everything that got covered, does the model actually cover serverless computing from cloud providers?
Yes, it does. That's one of the nice aspects of getting visibility from a cloud service provider such as AWS, is that they give you behavioral audit trail in terms of how is your serverless computing configured, what is the audit trail during runtime, and they also give you the ability to do any kind of a instrumentation in your function as a service code, and all of that can get aggregated at the backend and be contextualized with the rest of the application and its goals. Absolutely.
Folks, if you have questions, if you're here in the room, you can raise your hand. I can certainly repeat them. If you're watching us virtually, please put them in the Q&A app. And actually, it's best if you get them in the Q&A app. You've talked sort of a lot about how Uptycs covers, I don't want to say full spectrum, but in a lot of different dimensions of the spectrum, it's full spectrum. But what about attacks that come in from developer laptops?
That's a great question. We've been very careful at Uptycs to consume only what we produce. And in terms of what we produce, high fidelity telemetry such that the efficacy is really good, we've put a lot of effort. So on a laptop, there are two things from a modern developer perspective which have implication on the supply chain. One, software is being assembled out there, which means you want to have good visibility, if possible, into the behavioral changes of a laptop, what commands were being built, used, and what kind of images were generated on the laptop, because that's the productivity endpoint. And you also want to know what the interactions of that laptop or the persona or the user developer on the laptop was with your software, as in what did they do in terms of a git pull and what actually went down. And if you can do that correlation, the behavioral change plus the api and services that you interact with paints a really good picture to get the shift left visibility.
And kind of the last question here, I know one of the challenges facing a lot of us, and we'll be talking about it on a panel session shortly, is this move to multi-cloud. And I was sort of looking at that kind of grand finale slide you came out with the sort of the birthday cake, so to speak, the layers.
Yes.
But how would your solution work to enable multi-cloud development? I mean, I could see that the cloud providers were in there sort of as the bottom components, but could you elaborate on that, I guess is what I'm asking.
Yes. First, our marketing team will be thrilled that you used the layer cake analogy. Thank you for that. And props to them. But what's most important is the structural aspect of the telemetry and its representation. One aspect of trying to push imparting structure at source is that using something like Cloud Query, you have the ability to go across, let's say, 50 top popular services for each of the cloud providers. And at the end of the day, each service can be represented fundamentally in an abstract way, which means EC2 computing in one incarnation in AWS has a similar counterpart in GCP and has a similar counterpart in Azure. Same is the case for S3 storage, same is the case for networking. So when you go across these three cloud providers, you have the ability to normalize and decompose the tables in a way such that the high level analytics can be done on an abstracted view of the data. There's plenty of precedence for this in other domains. It's for the first time, I believe, across multiple clouds, there is an opportunity to abstract the API exhaust or whatever is coming out from the service provider, normalize it in a way, create tables such that you can do abstract analytics saying that cloud provider compute, cloud provider storage, and be decoupled from the fact that it's AWS, GCP, or Azure.
Everybody, please thank Ganesh. That was a really interesting presentation.